I'm in on all three. So like, I'm in on this. Yeah. So this computer is what is projecting to you guys. This is what's doing Notability, which is what's being shared. And this is what can see me and hear me. So I got to be in all three places so that you can see them and they can see this and they can hear me.
Oh my God.
It's a thing.
Wow.
Yeah, it's a thing. It's a thing. It's fun. Okay. Oh, thanks. You know, I try. Okay. So FRAPPY, our chapter 10 FRAPPY, we are doing confidence intervals of means. And your chapter 10 FRAPPY was to find a confidence interval. I think it was a 2 sample, wasn't it? Did anybody look? They haven't done it yet. They can't answer my question because they haven't done it yet.
Honestly, this is not the class to ask.
This is not the group to ask.
Maybe
Okay.
ask the people on the meeting.
Okay. Okay, so Jessica wondered if elementary school students, okay, shh. Thanks. Okay, so this is Jessica. Jessica wondered if elementary school students tend to write more when they are given a larger amount of space in which to write. To investigate, she asked 100 4th and 5th graders to respond to the following prompt. Do you like recess? Why or why not? About half of the students were randomly assigned to a larger quarter sheet of paper, and the other half were assigned to a smaller 6th sheet of paper. So 1/4 or 1/6. After the students finished, Jessica counted the total number of words in each response, and the summary statistics are given in a table below. Part A was to calculate and interpret a 95% confidence interval for the difference in mean number of words written for students like these who are asked to respond to the prompt on either the 4th sheet or 6th sheet of paper. So that's why I say it's a 2 sample thing, because you're calculating a confidence interval for the difference. Okay. Part B, so part A is going to take you a lot of time. Part A is a big chunk. Part A has a lot to it. Part B, you kind of write up a little conclusion, basically. Based only on the confidence interval from part A, is there convincing evidence that the size of the paper affects the mean number of words written for students like these? So I would even argue that in this particular question, part A, you need to do the state, the plan, and the do, and part B is the conclude. So you really are doing just a confidence interval from top to bottom, but the conclusion part is what they're asking you in part B. Okay. All right, so now I'm going to flip over to my screen here, and we're going to talk through the model response and the scoring guide. So in the, oh, I forget how to use Notability. Sorry, a lot going on. Here we go. There it is. Okay. So the intent of the question, it says the primary goal of the question was to assess students' ability to identify the correct procedure and check conditions. And yeah, sorry, my thing flashed a message at me. And check conditions for constructing a confidence interval. And then 2 was to construct the confidence interval for the difference of means. And then the 3rd, interpret the confidence interval and draw a conclusion. Okay. So your model response, part A, step 1 is to identify the correct confidence interval by name or formula. So in this case, it's a 2 sample T interval for the difference in means. That's your test. That's what you're doing. Okay. The conditions, you only have to check 2 conditions here. Okay. So the first condition is that the treatments were randomly assigned. Okay, this was stated in the question. The other one is the large sample. Both sample sizes, 54 and 46, are at least 30. Oh, nope, you're good. You're good. Will you just mute it?
Yeah, I did.
Yeah, perfect. The 10%, let's talk about 10%. So this was a case where you selected a group of students, you used every student in the group and randomly assigned them to 2 treatments. Because of that, those 100 students are your population. You used every single one. You don't have to address the 10% condition. Okay? Because you used every person in your whole population of 100 and randomly assigned them to one of 2 treatments, you do not need to address the 10%. And in fact, I'm sure it's down in the notes later, but it would be wrong to address the 10% in this case. And that's where it's tricky, because you've got to remember to leave it out when you don't need it. Okay. Here is your correct formula. So we're in T-star. We don't know the true mean, which means we can't know the true standard deviation. Since we don't know the true standard deviation, we cannot use Z calculations. We have to flip over and use T calculations. So this T-star, just once again, this happens a lot when you are doing means. If you are doing, you're good. Yep. Thanks. If you're doing confidence intervals or hypothesis tests of proportions, you often know the true mean and the true standard deviation. So then you can use Z procedures. But if you are doing confidence intervals or hypothesis testing of means, if you don't know the true mean, it's not possible to know the true standard deviation, which is why you have to use T procedures. Okay. So when you're doing a 2 sample, you first of all need to subtract the 2 means. Okay, that's what you're looking at. You're looking at a difference in means. Then you get your appropriate T-star value, and that T-star is based on the 95% and your degrees of freedom, which you're going to be better off putting this into your calculator, and it will tell you what the degrees of freedom are. So it's okay. And then you'd have that standard deviation 1 divided by N1, standard deviation 2 divided by N2, add those, take the square root. This is like the standard error piece. When you do the math of it, it ends up like that. They even showed you what is the margin of error. They gave you the difference in the margin of error. And then here's your confidence interval. There's your degrees of freedom that were given to you by a calculator output. You don't get 92.9 degrees of freedom when you look at the table. That 92.9 degrees of freedom came from their calculator. Okay. So when you are using your calculator, it is still going to be important for you to be able to identify these pieces. Okay. Identify the equation you are using, identify the correct parts that go in the correct places, and show what the confidence interval ends up being. Now, here's the nice part. You can write them out just to show the formula, but then use your calculator to actually get the calculation. That's fine. You don't have to actually do the work manually on your calculator. You can use that confidence interval, that 2 sample confidence interval in your calculator to get the correct calculation. Okay. And that, again, is where you'll also get the degrees of freedom. So then after you do the state and the plan, then you've got the interpretation. Here's like your conclude part. So they do have conclude up in part A. Sorry, my bad. I misspoke on that earlier. They have the conclude part up in part A with your whole confidence interval, state, plan, do, conclude. But then they also do a little conclusion that is almost restating the same thing in part B. It's okay. So here's your conclusion. We are 95% confident that the interval from negative 1.879 to positive 4.679, notice they say words. When you're talking about means, you have a label. Captures the true difference. They said what order it's in. because we know subtraction is not commutative, you need to put the order that you are doing your subtraction in mean number of words written for students like these. That's important because you're talking specific, you did your calculations specifically on a group of 100 students, but you're saying I can use that as a generalization for all students like these, but the students like these is the important part. Okay, so 4th and 5th graders, you get it, who are asked to respond to the prompt on either a quarter sheet of paper or a 6th sheet of paper. Okay. That's the model solution for part A. That's the state, plan, do, and conclude. Your state was up here. Okay. The plan part was kind of up here as well. They did the conditions. The do part was right here. And then your conclude part was at the end. Interpretation. Okay. So there's your confidence interval. Now let's talk about part B. So part B, I'll read the question to you again. It said, based on the confidence interval from part A, is there convincing evidence that the size of the paper affects the mean number of words? Okay, here's your confidence interval again, right here. There is, when you are talking about a difference of means, or even a difference in proportions, when you're talking about two samples and you're comparing them, there is one critical value for you to look for in your confidence interval. Does anybody know what it is? What is it? 0. Okay, so take a look. There are some plausible values that are negative. There are also some plausible values that are positive. That means that the true mean of the quarter sheet of paper could be greater or it could be lower. Since there are plausible values that are negative, our quarter sheet of paper could be bigger or it could be smaller. Basically, because 0 is in this interval, it is plausible that there is no difference. 0 is a plausible value. So it is plausible that there's no difference in the mean number of words that students like these would write on a quarter sheet or 6th sheet. Therefore, there is not convincing evidence that the size of the paper affects the mean number of words. Okay, do you get why that happened? Do you have questions about why that happened? If you think about it, you're doing, they're doing quarter minus large minus small. Captures a true difference, large minus small. Where's my table? Sorry, I'm looking for my table. Large minus small, yeah. So they did the 1/4 minus 1/6. Okay. So if this is negative, that means that this was larger. If this is positive, that means that this was larger. So basically we don't know. We don't know. We don't have enough evidence to say that one is better than the other. We don't have enough evidence that giving a student more space on the paper makes them write more, because there are plausible values because of 0. Because 0 is in here and there's plausible values on either side, we cannot say that there is a true difference. Okay. Okay. All right, now let's talk about how this would be scored. So obviously most of the credit is going to come from part A. You would have a whole lot of points in part A and a whole lot of places to basically go down to a P. Part A has a lot to it. So Here's what they say. This question is scored in 4 sections. Section 1 consists of step 1 in part A. Section 2 is step 2. Section 3 is step 3. And then section 4 is just part B. So there's 3 sections in part A and a 4th section in part B. That's where they get the 1, 2, 3, and 4 for your points. Okay. So section 1, these are the things that you needed. You needed to identify that it was a 2-sample T interval for a difference in means. You can either name the test or you can show the formula. Okay. You need to address the random assignment, and you need to note that the sample sizes are large. We were not told any information about this population, whether it was normal or not. But the fact that we have large sample sizes, that's enough. So address that the sample size is large. Okay. If you have only 2 of those 3 components, then you would get a P. If you have only 1 or none of the components, you would get an I. Here's all the notes. The notes are always the best part, right? Component 1 is not satisfied if the response states that the procedure is a 2-sample Z. They don't want Z. Can't do Z. You don't know the true standard deviation, so you can't do Z. Okay, so that will be wrong. And he even says that because the population standard deviations are unknown. Okay. The second note, to adequately address the random condition, the response must include random assignment. Okay, this is not a random sample. This is a random assignment within a sample. The randomness comes from the fact that they were randomly assigned to 2 treatments. It's an experiment, not a study. If this were an observational study and we're pulling a sample of people, then great. That's random selection or random sample. This is not that. This is an experiment, so it's random assignment. Okay? If you use SRS, nope. If you use random sample, nope. They're not looking for a random sample. That's not what's happening here. You have a group of students and you're randomly assigning them. Hopefully that makes sense. The next one, if the response includes wrong statements about the conditions. Oh, here's your 10%. See, I told you this would come. If you address the 10%, those are incorrect statements. You specifically do not need the 10% condition here. It is wrong to state it. Take that for what it's worth. That's a bitter pill to swallow because it's hard to determine whether you need the 10% or not. Most of the time you do. It's rare that you don't. Okay, so just think if I've got a group of things and I'm using every single one, then I'm not looking at 10%. Okay, and often it's like these two go together. If you used random assignment, then you don't need 10%. If you used random sample, then yeah, you need 10%. Okay. So Jessica didn't sample without replacement from a population. Or if you just said incorrect statements about the conditions, such as large sample sizes implying population normality, you're not saying that because we have a large sample size, our sample is normal. You're not making that claim. You're just saying we have a large enough sample size that we are allowed to use T procedures. You don't know if the sample size is normal or not. Don't claim that it's normal. Okay. The next note down, any statement of hypothesis definitions of the parameters should be considered extraneous. See, I was kind of wondering that. They didn't name the parameter here. What they're telling you is you can name the parameter, but you didn't need to. Okay. I don't necessarily understand why you don't need the parameter here, but what they say is it's extraneous. You don't need it, but we're not going to dock you for it. However, if you do name the parameter and you name the parameter incorrectly, then they're going to dock you for it. Okay. So if you define parameter in terms of the groups of 46 and 54, they're considered poor communication in terms of holistic scoring. I'm pretty sure it has to do with the fact that it's an experiment of 100 and you're using all of them. So you're not referencing a larger population. That's why you don't need to state the parameter, I believe. Okay. All right. Section 2. So that was all just like for our purposes, that was the state and the plan. Section 2 is the do, if you will. So essentially correct if the response gives the correct 95% confidence interval. Supporting work. Ooh, it says supporting work is not required, but if included, it must be correct. Ooh, look at that. Supporting work is not required. What they're saying is you can use your calculator. You can show the formula and you can use your calculator. There you have it. Partially correct if the response gives the correct confidence interval with incorrect but supporting work shown. Or if the response gives an incorrect confidence interval with appropriate supporting work shown. So if you used like the wrong equation, but you did the work right, they might give you a P. I think that's what that means. And then incorrect if it doesn't do either of those things. I'm sure there's notes. Let's look at notes. Yep, here they are. Here's our notes for the do. This is all part of the do, okay? So here are some other acceptable confidence intervals along with the degrees of freedom and critical value used to calculate the interval. If the response provides an interval that doesn't match the reported degrees of freedom or T-star value, the response can earn at most a P. Okay, so I was reading, I think I've told you guys that I'm in a AP Stats teachers group on Facebook, okay? I've gone to there are lots of very, very, very smart people all over this country that have taught this class for years and years. And I've gone to this group, or I've been in this group for a while, and I go there for advice and tips, and we're always everybody plans for the same AP date, right? Every person across the nation, even across the world, like there are people who are doing this in India, and they have to take their AP exam at like 3 o'clock in the morning or something. Yeah, because they all have to be administered at the same time. Yes. Yeah, literally across the world. They're all over. Anyways, lots of very, very, very smart people. I go in there to make myself smarter. Okay, so I was just reading yesterday that people were talking about the difference between doing the confidence interval, the T-star, specifically T-star, and specifically with 2 sample, which is what we have right here, by hand and doing it on your calculator. And one of the guys in this group is a guy, he didn't write our textbook, but he wrote, where do I have it? This textbook, Stats Modeling the World, which there are basically 2 textbooks that any AP class will use. And it's either the one we have or this one. The guy who wrote this book is in this group. My point is he's brilliant, okay? So he got on there and replied to this person asking this question and said, doing T-star calculations by hand is an outdated practice. I'll say it again. Doing it by hand is an outdated practice. Never will these kids go anywhere and do this by hand. They're going to use their calculator or some computer program to do this. So you've heard me say it before, but he reaffirmed me last night and I felt good about that. But use your calculator. You don't need to use the T-table. You don't need to prove that you know how to use the T-table. Now, AP exam, if you're in the middle of your AP exam and this thing dies, you're on your own. Yep. And that's a bad situation. So that's one thing that I really push and check. Like, you wouldn't believe the number of calculators that sit on my charger the week before the AP exam. And then I'm always like, get your batteries, check your batteries. Are your batteries good? Like, put extra batteries in your pocket, whatever. Because then you will have to do things by hand. And that would really be awful. But you don't need to do things by hand. You don't. You don't need to do things by hand. You're not proving anything to anybody by showing that you know how to use the T-star table. It's good that you know what the T-star table is, because it's good for you to understand where those values come from. And there still may be times, like I can still see a multiple choice question where they say, what is the T-star value for this situation? And then you're going to go to your table and you're going to look up the degrees of freedom and all that and the other thing. So it's still good to know the N-1. It's still good to know that when you've got 95%, you've got 5% in the tail, cut it in half. All of that stuff is still good to know, but the point is use your calculator. Okay, now what our people are telling us is that here's all the acceptable forms of your confidence interval. You could use 45 for your degrees of freedom because you did 46 minus 1. You could use 40 for your degrees of freedom because 45 isn't on your table. So you'd have to go down to 40. You can use 98 for your degrees of freedom because you did, what did they do? 100, a pooled 2-sample T interval. Okay. So there's all sorts of different ways to calculate this confidence interval, and all of them are justified by some way, shape, or form. But the bottom line is your most accurate response is going to come from here. So do it on your calculator, okay? It's still good to know what the formula is. You still have to identify that you know what the correct formula is. You still have to name the appropriate test. So all of that stuff is still good knowledge to have. You just don't have to sit and actually manually type things into your calculator. You're going to enter your data and the calculator is going to spit it out to you. Okay. One last thing. So they said, I want to look at this Z-star one. Z-star is 1.96. Confidence interval is that. Note, if 2-sample Z-star interval is used, the response cannot satisfy the identification requirement of section 1. Okay. What they were saying with this last, I was like, why do they have a Z-star one there? What they're saying is, if you for some reason said that it was a Z test, even though it should be a T test, this is what it would look like. They would give you a P for that because you did the correct Z interval, but this isn't a Z test, this is a T test because we don't know the standard deviation. Okay, cool. Does that kind of make sense, at least the whole calculator piece? Does that make sense where I'm coming from? Hopefully it does. Okay. And I am really glad that he said that. It is an outdated practice. You don't need to do that. You're never going to go to a job where you're going to do that by hand and pull out a table. You're just not. Okay. So it's good. All right. Section 3. So here's the conclusion section. So you need to have these parts in your conclusion. You need to have that you are 95% confident in some way, shape, or form. Name your confidence level. They even say we are 95% confidence or with 95% confidence. Like there's lots of ways to write that, but make sure it's in there. Describe the difference in means and in context. So you say in a difference of means of 4th graders who responded to a prompt on a quarter sheet of paper or 6th sheet of paper in number of words. That's where there's a lot of writing. When you put it in context, you got a lot to write. The interpretation is not about the groups of the 46 and 54. So it says, for example, a response that describes the difference in means for the two groups or for those assigned does not satisfy the component. You're talking about students like these. That's, I think, what they're getting at there. Partially correct if you include 2 of the 3 components, or if the correct interpretation of confidence level is in context without the interpreting specific interval. So basically, if you left out the interval, but you put everything else in, great, okay. And then incorrect if you missed it. Here's our notes for this section. A response that includes an incorrect interval is not penalized in section 3. In other words, grade the interpretation as if the interval were correct. Interesting. So what they're saying is you can do a wrong interval in section 2, but if you use that interval to give a correct interpretation in section 3, you can still get an E. Just for that section, you can't get an E for the whole question because your interval in section 2 is wrong. But if your concluding statements are correct based on the interval you found, you'll get an E just for section 3. Okay. To satisfy component 2, the response must refer to the difference of means in context. Difference of means, talk about what they're about. Number of words, 4th graders, response, quarter sheet, 6th sheet, all that stuff. Write it up however you want. Remember that this isn't a grammar test. It's also not a spelling test. You are not dinged if your sentences are not grammatically correct. You are not dinged if you misspell words. If they can follow what you're saying and it's clear enough, then it's okay. Here's another note. When both the interpretation of the interval and the interpretation of the confidence level are given, only the interpretation of the interval is scored. If the interpretation of the confidence level is correct, it is considered poor communication in terms of holistic scoring. You are not addressing the confidence level. You're only addressing this one particular interval. The confidence level would be if you're pulling sample after sample after sample after sample, and then you say, we're 95% confident that the true mean will fit into 95% of our things. But you're not picking sample after sample here. That's why they say you don't need the confidence level. And then any interpretation that implies that the interval has a 95% chance or possibility or probability of capturing the true mean difference is scored as an I. The 95% is not a probability. The 95% is your confidence that your true mean difference is in that interval. It's not a probability. That's what they're saying there. Okay. Whew. That was just part A. That was the confidence interval part, and that is a bulk of your score. In part B, what they're calling section 4, this is your fourth point for your response question. It says, it is essentially correct if the response to part B shows the following 3 components. State that 0 is in the interval. 0 is a very clear point of interest in a 2-sample interval. If you've got 0 in there, that's very telling to you. States that there is not convincing evidence of a difference in mean, and then answers in context. So talk about the words in the quarter sheet and the 6th sheet. Okay. So 3 pieces there. That concluding statement is really similar to the concluding statement you'll have up above, but it just like basically puts a little more context in. Like, can you say that there's convincing evidence is basically what they're looking at there. Okay. Partially correct if you have 2 of the 3, incorrect if you don't. Here's your notes. A response that states there isn't convincing evidence that paper size affects mean word count satisfies component 2 and 3. So you can very simply state that you don't have convincing evidence in context together. If, I think that's supposed to say if the response provides an interval that doesn't include 0, then the response should state that there is convincing evidence. If you did your interval wrong, if your interval is wrong and 0 is not in it, then you better say that there is convincing evidence. Okay, so you better answer accurately based on the interval that you found. If you do that, you can get an E. If you found a wrong interval in section 2 up above, but you used that interval to make a correct concluding statement, you can get an E. You don't get an E for the whole question, but you get an E for that one part. Okay. Responses that are equivalent to accepting the null hypothesis. Be careful. Some of you talked about null hypothesis when we were doing confidence intervals earlier. But we weren't testing. In chapter 8, we didn't test. Why are you talking about hypotheses? If you are not performing a significance test, then you are not doing hypotheses. Okay. I caught some of you on that on your test. And I was like, oh, that's funny. We haven't even talked about hypothesis testing yet. Oh, why are we writing about it? Interesting. Right? So, okay. Don't talk about hypothesis testing. You're not hypothesis testing here. You're doing confidence intervals. So that's what they're getting at there. Okay. Each part is 1 point. E gets a 1, P gets a half, I gets a 0. If you're between the two, you can use your judgment to go up or down. You don't get a half score on these. Okay. Questions? We've reached the end. Does anybody have anything they want to ask about? Okay. That is the end of our FRAPPY conversation. So I'm going to turn off my recording.